Okay, so Professor Ortwin Renn,
Yeah,
it's your
well,
turn.
thank you very much, Xingshu, for this very nice introduction. I was blushed, when you talked about all these accomplishments. Of course, a lot of these things are things that have been done with other collaborators, other co-authors, also from the IDRiM Society. So in that sense, it's also always a little bit of teamwork. I would like now to share with you my slides, and just make sure that they're up there. And hopefully they'll come up. Always takes a second. Can you see them?
Yes.
Okay, that's fine. So the topic that I would like to talk about is inclusive resilience, a new approach to risk governance. And what I would like to do in the beginning of this lecture is to think a little bit about the terminology here. What is risk, what is vulnerability, and what is vulnerability and resilience? And then to go on based on these kind of definitions on how to deal with risk assessment and risk governance when we're dealing with these various topics. First, let me give a definition. Resilience is the extent to which a crucial structure or service to society has the capacity to maintain or quickly restore its functionality under severe stress situations. So different from risk, resilience tells us something, how a system responds if it is under stress. So it's not so much the probability of what that stress is and how it will come about, but rather we're focusing on the structure or the target, or what we call the risk-absorbing system, how it will actually perform under stress, and if we have the organizational capacity to restore its functionality quickly and safely. Now, we can continue this and to see how that all relates to the other terms that we are used to have in the risk debate. Risk is a probability of a risk agent, a hazard, impacting on a risk-absorbing system, a target, and causing specific extent of damage. So that's basically what our definition of risk is. So there is something that causes a risk, which we call a risk agent. It could be energy, an explosion, it could be a technical failure, it could be a natural hazard that impacts on some kind of a risk-absorbing system. That could be a human being, that could be an ecosystem, that could be a building, that could also be a target like human wealth. I mean, everything that is basically exposed to the risk. And through that interaction between a risk agent and a risk-absorbing system, we cause harm. And that harm can have a specific extent depending on the stress at one hand, on the risk agent and its intensity, but also on the vulnerability of the risk-absorbing system. So vulnerability is basically defined as the extent to which the risk-absorbing system is able to resist the stress induced by the risk agent. So is that high vulnerability means even a small stress can make a system dysfunctional. A high vulnerability, a low vulnerability would mean that this needs quite a bit of stress before the system actually responds negatively. And resilience then means the extent to which the risk-absorbing system has a capacity to maintain or restore its functionality under severe stress situations. So that gives us a little bit of a background, because resilience is really focused on the risk-absorbing system, not so much on the nature of the stress that we would encounter. So this is basically probably a graph that you have seen before. There's a shock, so external shock, the external stress, and then of course the system performance goes down. It really collapses maybe, and then we have countermeasures, and those countermeasures then bring the system again up to speed. And there is something like collapse, that it doesn't get up to speed. Ductile behavior means it goes on, but at a less performance level. This robust behavior is the same performance level, and adaptive behavior would even even mean that it gets better than before. And Nori Okada, who is also a very important member of society, calls this building back better. So if you have such a loss, you can even build it better so that the next shock or the next stress will not have the same disastrous impact. Now, we can also think about what that means in terms of objectives for resilience. And there are three major objectives that we would see in terms of resilience. And the first is to prevent the stress to have any impact. And that is to guarantee the functional continuity of a service in times of stress and disaster. Some people say that's not resilience, that's basically, risk prevention. But I believe that a lot of measures to guarantee the functional continuity in times of stress has the same kind of measures than the ones that you would like to restore quickly and even build better afterwards. So I believe it's a part of resilience to make a system more adaptive to stress so that it doesn't have or it doesn't lead to negative impacts. So the second point is to limit the extent of losses and impacts if service is discontinued. That means even if a building collapses or a pipeline breaks or some other kind of target is really damaged, the service that is needed for society should be, even if discontinued, it may not have the kind of negative impacts that we would experience when we had a total collapse. And the third thing is to ensure fast recovery if the provider of the service is unable to continue to provide the needed service after the stressors have hit the target. So if something really breaks down, we have the services discontinued, then we want to have a very short period of time until that service is then being resumed. And so these are the three major objectives, and they are very much interconnected. However, we can see that there are different kind of expectations and also different types of governance requirements to deal with objective 1, 2, and 3. Let's start with the first one. That's a criteria for, the first one is securing functional continuity. That's number 1, so that it will survive the stresses without disconnecting the service. There we have 3 aspects that we need to look at. One is structural stability, and that's the ability to cope with stress, disrupting, impeding, and otherwise affecting the delivery of crucial services by technical means. So basically, structural stability means that we build high walls, that we build redundancy, that we build in diversity so that if the stress is coming, the service is still there. But secondly, we always look into the technology, but I think very important is also to look into the organizational coping capability, which means the ability to cope with performance deficits affecting the safe operation or delivery of key services, because very often it's not the building that collapses, but the organization that runs the building or the system the technical device. So in that sense, we always have a connection between the structure and the organization. And thirdly, it's a system of what we call value chain disturbance. That's a lack of pre- and post-service input or output causing breakdown or disturbance. So when we see, for example, the Corona crisis, we could see that a lot of goods that were shipped, let's say, from China to Europe or to the United States were interrupted. So specific services were not being able to be offered to society. And so the value chain and all the goods that we're needing for producing services and products are in a chain. And if one of the element of this chain is disturbed, and then we can have a real problem up or downstream. We call this system disturbance. And what's important is we need to put in all three at the same time. The structural stability, for example, if you have a dam, that dam is withstanding stress, and we just seen in the Ukraine that, you know, there has been a problem there. Organizational capability, if the stress, we need a very good a capable team that can deal with it. And thirdly, we always are dependent from up and downstreams suppliers. And if one of them is being out of service, then we have the same problem that the service is not there anymore. So those are the three criteria for the first objective, securing functional continuity. Now we get to the second one, which is criteria for reduction and impact. So can we, even if things are really, if service is interrupted, we still want to have at the least detrimental impacts as possible. And again, we have three criteria here. The first one is technical robustness, which means structural provisions designed to withstand stress or limit losses in terms of human lives, capital, or ecosystems, if crucial services are discontinued or are affected. So basically is to reducing the impact. And that can be that we have specific ways. That takes the dam example again, that downstream we have, for example, flooding areas that can be flooded without harming anyone, or that we have structural dams down the stream that would also keep cities safe from flooding. So those are kind of technical robustness, very similar to the technical stability that we had in the first objective. The second one is flexibility in service production. That is, are we flexible enough to really cope with the new situation? That is to secure crucial services by other means. For example, that, you know, if there's no fresh water, that we have bottled water available. Or if we have an earthquake somewhere and that we have shelters available. All of those things are important, that we have a flexible production of services of things that people need. But the primary source of meeting those needs is destroyed. So we need a secondary or a third possibility to do this. That is what we call here substitutes or multifunctional systems. And the last one is the social adaptation and responsiveness, is the capability of institutions to cope with secondary impacts. Very often, this is not the primary impact that of major importance, but also secondary and tertiary impacts, just like institutional failure, political failure, social anarchy, psychological problems. All of that also is important, that if, let's say, a major disaster happens, that we have, for example, psychologists in place that can help people with traumatic experiences, that we still keep social order up, that we have a political system that can make distinctive decisions, and that institutions still work. So this is for the second objective. And now let's go to the third objective. This was ease of recovery, so that we can quickly recover from a disaster. That's the first thing, is availability of resources, and that is technical and financial capability to start and complete a recovery in due time, including new financial instruments such as catastrophe bonds. So something that if a disaster strikes, we do have the technical capability or the financial capability to build back better, which is, of course, the most important objective here. We secondly need organizational skills, that is capacity of emergency and recovery institutions to rebuild or substitute crucial services in due time. So that's close also to what we said in the second objective, that losses are reduced. But here is basically that we have organizational skills for recovery, for rebuilding, that those skills are there and that they are being prepared in advance of the disaster. And thirdly, we have organizational learning. That's the capacity to learn from the disaster and to improve the future resilience performance of the remodel system. That's, as I said, what Nori Okada has brought into the discussion, building back better. So trying to have an organizational learning scheme that helps us to rebuild the system in a way that future stress situations can be better managed. Now, this is basically let's say nomenclature, the basic terms that we need to think about. So we have always in resilience 3 major objectives, and each objective has 3 major criteria. And that can help us to do better management strategies. And I would like only to point out some of the major management strategies that we have when we look at resilience. The first one is when we focus on resilience specifically with some of the very new polycrisis things, where we have multiple stressors coming in and they're very difficult to predict, then it makes sense to focus on resilience. And that means first, overcome vulnerabilities, so really focusing on the risk-absorbing systems, and secondly, to invest into the organizational, technical, and systems capability of resilience. How can we do this and how can we prepare this? One is what we call a stress test. So we are trying to simulate various stressors and checking whether the risk-absorbing system is able to cope with that or whether we can restore it quickly. That's a stress test that we first start with stressors like, a combination of an earthquake and technological disasters, just like Fukushima, or that we see that different things get together, organizational failure plus a technological failure. So common mode failures are one of the things what we can test there. Please note that probability here is not the main issue. We are really testing for low probability events. The more complex system are, the more likely is that there is at least one unlikely event that will affect them. And it's meaning that if we have 1 million of very unlikely events, it's or with a probability of 1 times to the -6 or 1 to the 1 million. If we have 1 million events that are relevant, then one of them is very likely to occur. And that's what we can see all over the place in our very nested and interconnected society, interconnected technology, that everything is connected to everything means that the number of unlikely events that have an impact have increased tremendously. So that we don't know which of the unlikely events will happen, but we're pretty sure that one of them will happen. And that makes it very difficult. That's why we really focus on the risk-absorbing system. We can also do the reverse stress test, and we start with vulnerabilities and look, where do we see vulnerabilities and what are potential stressors that could be attacking these vulnerabilities, and what can we do then to improve the situation. The last thing what I said here is black swan scenarios. That's construct a set of diverse black swan scenarios and test robustness of your risk-absorbing system. A black swan scenario is even more unlikely than the stresses that we had simulated before. But what is good is we can say, well, we're pretty sure that the black swan that we test will probably never occur. But we can test whether our system is able to deal with black swans. And I think that's a very important element, because if it's good for one black swan, it may be good for another. It's not guaranteed, but there's at least some good indication that that will work. A point that's very different from the others, but extremely important, is include stakeholders. Why do we do this? Well, if you want to assess vulnerabilities, if you want to assess organizational capability, if you want to assess system stability and flexibility, we are always reliant on people with experience that do the right thing and know what to do when disaster strikes. And those are very important stakeholders. Stakeholders that have experiential knowledge or local knowledge or tacit knowledge, sometimes indigenous knowledge, that is very important in dealing with local disasters. And I know that IDRiM has been very active in this kind of localizing risk governance responses. But I think here for resilience is even more important because the risk absorbing system is very often a local system that's embedded in local structures where we need to have stakeholders that help us to understand the kind of situations, hazards, dangerous and vulnerabilities that only stakeholders know. And secondly, stakeholders need to respond. It's not just scientists and trained personnel. It needs the people who live close to the disaster area, or the emergency crews and so on. All of them are very important to include so that they know what to do if disaster strikes. So what does it mean now for risk inclusion, which is also in my title? As I said, stakeholder inclusion is extremely important, participation. And what we advocate is an analytic deliberative approach, where we say we have an analytic component that helps us to understand the resilience. And we know, as I said, there are multiple stressors, there are multiple disciplines, each is associated with one or two of these stressors. So we have a plurality of evidence, or we need a joint fact-finding exercise to make sure, how is our vulnerabilities, how is our resilience? We need a multi-criteria assessment then of the benefits and risks of something that we can do. All the measures have benefits and have risks that we need to include. And we need to be transparent about trade-offs, because in any time we very often, if we increase resilience, we decrease the efficiency of systems. And that, of course, something that economists don't like. But in general, we need to make a good trade-off there. But then we have a deliberative component, that's inclusive component, where we say, okay, what should we do? If we have trade-offs, we have to send off priorities. And our measures should be effective, they should be efficient, but they should also be fair, resilient, and sustainable. And all these attributes, have a long list of sub-criteria. But what's important is it's not just one thing. It's not just reducing risk or reducing losses. We want to be effective in terms of this, but we also need to be efficient because our resources are scarce. It needs to be fair in terms of distribution. We very often see that the poor is more affected than the rich, and or the local, the rural people more affected than the urban people. So fairness is a very important aspect. Resilience in meaning, if you have multiple stressors, and sustainable in the sense that the solution, that building back better, is really building back better in terms of sustainable criteria. We need hybrid forms of stakeholder public participation. We need stakeholders like, the various groups, emergency crews, contingency planners, Red Cross, whatever it is, that needs to be included, but also the people who live next to it. And I know that Nori Okado, I've mentioned before, had this village universities, disaster universities, where specifically people from the community are being involved. I think that is extremely important and helpful. And it has to be aligned to political decision-making. So all these participatory processes need to have an impact on the political level. We can deal with that in what we call a stakeholder involvement letter. And that's something that we have used for the risk governance approach of the IRGC, the National Risk Governance Council, which I will just go through very briefly. If risks are very simple, if it's very complex, if you have a lot of uncertainty, and if you have a lot of ambiguity, there are different forms of stakeholder involvement. If it's very simple, if you only deal with one single risk, we just need agency staff, and we need the most cost-effective way to make the risk acceptable and tolerable. Well, in terms of resilience, that is probably not very important. Complexity is already very different, because there we have a complex system. We need models to deal with those complex systems, and we need a lot of scientists, researchers that help us to model this. And that can also be modeling resilience in the three objectives that I mentioned, but also in the classical risk analysis sense. So we use experts to find valid, reliable, and relevant knowledge about the risk. if we have a lot of uncertainty around it, we call this a reflective discourse. We need, in addition to agency staff, scientists, and research, also the stakeholders. This is where stakeholder participation is very important, because basically we say we are uncertain about the harm, we are uncertain about whether our measures really work, also to increase resilience. So we need to have the people who benefit from the service and those who would bear the risk sit at a table and make sure that there is a fair settlement between those two groups. And if there's also a lot of ambiguity, so like the glass is half empty or half full, depending on how you look at it, then we also need to include civil society as a major actor, because sometimes even the benefits, and again, if we increase resilience, we may decrease efficiency. If we increase fairness, we may decrease effectiveness. Those are all very important trade-offs where, you know, there's a lot of ambiguity what you want to do, where you want to put priority, and that is where we need to have a societal discourse. So that helped us a little bit to design the right discourse that is needed in order to make the best risk governance decisions. Now, let me come to my conclusions. First, I would like to again remind you of the properties of resilience. We say there are three main criteria. First is to remain the functionality of a system if it's under stress. That's the best thing. If it can remain the functionality, I mean, that's great. Very often that's not possible. If that's not possible, the second best thing is to limit the impacts, so that the impacts are not too bad, and that we may have substitutes for very crucial impacts. And thirdly, even if that's not really working well or it's not well enough, then we want at least to make sure that the recovery is quick and not too resourceful. And that, I think, are the three main criteria. They're all interconnected, as I said before, but they need to be analyzed separately. Each of these three are divided into 9 subcriteria. I will not repeat them again, and we had them on the screens, and that helps us then also to check resilience, to evaluate resilience, and also to design resilience programs. And these subcriteria can be further structured into indicators and sub-indicators, of course. Now, I don't want to get it more complicated, but if you want to do it, I think even the subcriteria may be too abstract in the beginning. But then if you further delineate some subcriteria and indicators, then they can be extremely helpful. What are the required management strategies? First is when we focus on resilience and risk-absorbing systems, that's not always necessary. I mean, very often when we do just traditional risk assessment, we also look at the risk-absorbing system, but we basically focus on the risk agent. Who is causing the risk, and can we do something to reduce the cause of the risk? Like in climate change, you want to reduce CO2. But we know now we have already so much CO2 in the air, and that we have to look at the risk-absorbing system, and that, of course, is then to adapt the system towards the new situation. We have to focus on a variety of unlikely stress scenarios, even including black swans, because the more the world is interconnected, the more likely is that one of these unlikely scenarios will happen. The scenario itself remains unlikely, but we have a large number of unlikely scenarios, of which probably one will actually materialize within a very short period of time. And the third thing, what I said, is a focus on the integration of multiple stakeholders and public participation. They add very important knowledge to our governance structures, but secondly, it's also important that they know what to do in disaster situations and that they are better prepared to do what is required in order to protect them. This completes my presentation. Thank you very much for your attention, and I'm now looking forward to your questions.